Welcome. In this lecture, we are going to discuss some industry driven digital control architecture and their system solution for high power application, and we want to link our course concept with this kind of architecture. So, we will summary of digital control architecture in this course, then example of digital control system solution and how can you link with existing digital control technique with this course. Okay, so digital control system solution, we have discussed about digital voltage mode control in lecture number 71 and 75. We have synthesized the Verilog HDL code. We have discussed digital base voltage based constant on time digital control, and we have discussed with Verilog HDL synthesis, we did it lecture number 96. Then we have discussed 2 loop mixed signal current mode control, and we have developed this digital control with using Verilog HDL synthesized code, and we have also prototype using FPGA in lecture 75 to 78. Then we have also discussed constant on off time mixed signal current mode control and the architecture exploration, and we have discussed this aspect in lecture number 97 with the hardware demonstration, and we have developed this core architecture using Verilog HDL. Then we have also discussed phase spectrum technique in digital pulse width modulation control, and we have developed the Verilog HDL synthesized code, and we did FPGA implementation in lecture 111 and 112. Then we have also discussed multimode digital control PWM and PSM, which is a voltage base, you can do also current base, and we have synthesized this multimode digital control using Verilog HDL and prototype using FPGA in lecture 113 and 114, and we have shown also experimental result. We have also discussed mixed signal peak current based multimode PWM and PFM control, and we have developed this architecture and synthesized using Verilog HDL, and we have presented FPGA prototyping with experimental result in lecture 115 and 116. So, with this understanding of the key architecture that we have discussed, and we have also developed their Verilog HDL synthesized file, and we have prototype. With this concept, it is reasonable to link with some of the commercial product. So, one example is the 3-level 3-channel Interleaved boost PFC, which is from ST Microelectronics, and this is a 3 kilowatt, and I am not going to discuss about this because one can get detail with this part number. Now, in this part actually it is mentioned that mixed signal average current mode control with current loop analog, voltage loop digital. In our course, we have discussed the mixed signal peak current mode control in lecture 75 to 78. I think this lecture can be a basic, very helpful to understand what might be there, because most of the commercial product, the detail of the control logic may not be available explicitly in the public domain, but with the knowledge of this course, particularly the mixed signal current mode control architecture, one can think about what could be the solution here or come up with a new solution. Another aspect is the GAN based totem pole PFC, Interleaved PFC, which is like using C2000 microcontroller. In fact, this architecture was considered with a small hardware demonstration in this course in the week 9. And in this course, it is a 3.3 kilowatt converter, and it is a fully digital current control. And the other feature of this controller, it uses a fully digital multi-loop control solution, and it also has feed forward, soft start. Now, if we recall our digital current mode control architecture, we have discussed in lecture 75 to 78 mixed signal, how to implement digital current mode control using mixed domain approach. We have synthesized this architecture with Verilog HDL, and we have also prototyped using FPGA. For fully digital, we have carried out MATLAB simulation, developed the model in lecture number 27. So, this concept may be useful to link what is there inside or come up with a alternative solution. If you go for 30 kilowatt 3-phase SiC based Vienna-Rectifier, this is coming from microchip technology, and if you all the digital control solution may not be readily available, but it says about digital control solution, which means the digital control is very much used for this particular high power converter. And we have discussed in detail from lecture 12 to 20 the different digital control architecture. Some of this architecture may be useful to link with this what is there inside, or maybe thinking alternative solution, because the detailed architecture may not be publicly available. Then we are talking about a bridgeless dual boost PFC, and this is for Infineon technology, where it talks about high power density 3 kilowatt PFC, and it actually consider fully digital control, and which has a duty ratio, feed forward, notch filter and sampling, but all details of this control architecture may not be publicly available. But we have learned the lecture number 12 to 20 all digital control architecture. In fact, from week, I would say week 8, then week 10 to week 12, we have discussed lot of Verilog HDL synthesis of multiple digital control architecture, including voltage mode, current mode architecture, fixed frequency, variable frequency architecture, then multimode digital control architecture. Then we have discussed about spectral spreading. So, this architecture will be helpful either to understand this concept what might be, or to find alternative solution. So, this is another one from ST Microelectronics, the 3-phase Vienna-Rectifier, where it is a mixed signal control, and the inside all these control logics are not available, but it said that event driven state machine it uses a mixed signal control. So, if you go to the mixed signal current mode control in 75 to 78, as well as if you go to week 10 to I think week week 12, we have discussed lot of Verilog HDL coding and synthesis of the digital control architecture for various digital voltage current mode control. So, this will be useful. Now, digitally controlled solar microinverter. So, this is from Texas Instruments, where it uses for microinverter and all these MPPT algorithm. It is a fully digital control solution, and you will get the idea of the basic digital control architecture, voltage mode, current mode architecture in lecture 11 to 20, and we have also discussed details in week 10, week 11, week 12, various architecture. Some of this architecture may be helpful to come up with an alternative solution for digitally controlled solar microinverter. So, then solar microinverter in plug-in PV, it is for ST Microelectronics, where it also uses fully digital control solution and burst mode control for light load efficiency improvement, and we have discussed various digital control architecture in lecture 11, 12 to 20, and we have also discussed in week 10, week 8 and week 10 to 12. So, this will be useful for how understanding implementation of digital control, which may be helpful to come up with a digital control solution for microinverter. Then solar grid microinverter from microchip technology, that also uses digital control, and we have discussed this digital control in week 12 to 20, and we have this whole lecture is on digital control. So, I think if one can understand this lecture very well, I think they can come up with a new or maybe alternative digital control solution. Then this is the 3 kilowatt LLC converter from ST Microelectronics. Then it uses fully digital control solution and adaptive synchronous rectification. That means you can also do the dead time optimization, then light load control improvement, and we have discussed lecture 12 to 20 the different architecture, and this light load control we have taken week I would say 11 and 12. So, which consider extensively light load control technique, digital control, how to synthesize, how to implement synthesize using Verilog HDL, how to implement using FPGA. So, this technique will be useful. I am not exactly burst mode, but we have talked about constant on time, pulse skipping modulation, then adaptive on time control technique and also multimode technique. Then this is another resonant converter from Texas Instruments, which also uses fully digital multi-loop control, and we have discussed digital current mode control in lecture 14, 15, 17, 20, and then we have also discussed in lecture 75 to 78, 75, 76, 77, 78, all these digital current mode control architectures are discussed. So, one can get details about this, about current mode control, because it may be linked with multimode, or it can be other architecture which are proprietary, may not be available. But if we go to our week 10 to 12 week, you will get to know lot of digital control architecture that may be useful. Then digitally controlled resonant half bridge converter, this is from Texas Instrument, which also use a fully digital control solution, and we have discussed various architecture of digital control from lecture 12 to 20. So, some of this architecture including extensive implementation from week 8 as well as week 10 to 12 will be helpful. Then GAN based 3 kilowatt converter from GAN system, this also uses the digital control mixed signal control, and we have discussed lecture 12 to lecture 20 as well as week 8, week 10, week 11, week 12, all digital control techniques or implementations are discussed. Then this is a phase shifted full bridge converter from Texas Instrument, which also uses fully digital control multi-loop, and again we have discussed multi-loop digital control, both fixed frequency, variable frequency as well as peak current mode control. We have implemented in this thing in week 8, then week 10 to week 12, different architecture. So, this may be helpful. Then another fully digital AC/DC power supply from ST, that also use a digital control solution, and various digital control architecture we have discussed, and week 8, week 10, week 11, week 12 we have synthesized various control architecture which may be useful for PFC converter. So, what we wanted to say, we have shown all the digital control system solution to show there is an increasing trend of digital control for high power converter, for power factor corrector converter, for LLC converter, for electric vehicle EV charger, then EV powertrain, then solar microinverter, DC grid, so then LED driver. So, this increasing trend, I would say our summary of digital control architecture in this course will be very helpful to understand those architecture as well as come up with a new architecture for future this commercial product. So, we have taken many examples of digital control system solution, and we tried to link our knowledge that we gain in this course with this existing system. That is it for today. Thank you very much.